Hey everyone, going over my chapter 6 teach the doc here. This is Megan Bauer. Starting off with this table here, if the wavelength is long, then the frequency and the energy are both going to be low. And then if the wavelength is short, the frequency and energy are going to be high as they are inversely related to each other. This printed out weird, I'm sorry, so I'll just flip over to this other page. Just using this as a reference, so completing the table. This is the quantum mechanics and the atom. So the possible m values for the first one are 0, which would be the s orbital, which is 1 orbital. The next one, if it's 1, you have -1, 0, and +1 for your m, which would be a p orbital with 3 orbitals. If it's 2, you have the integers from -2 to +2, and that is, it's hard to see because I scratched it out, your d orbital with 5 orbitals. And then if it's 3, then you have -3 to +3, and that is going to be an f orbital with 7 orbitals. For the periodic properties of the elements, so the larger atom between magnesium and barium is going to be barium, and then chlorine is smaller of those two as well. So the radius of the atom is 1/2 the distance between the nuclei in a molecule. That consists of 2 identical atoms joined by a covalent bond. So the radius for halogens increases down the group, and then it decreases across a period. So just use the periodic table with those properties listed in order to find which one would have the largest and the smallest radius. Going on to this last page is a little bit busier. So cations are smaller than their corresponding atoms because they have fewer electrons. The electrons are removed from the outer valence shell, and then the remaining electrons have a greater nuclear charge and greater affinity, drawing them closer to the nucleus, so it's going to decrease that overall size and radius. Whereas the anions are going to do the opposite. They're going to be much larger because they add the additional electrons and they create like more repulsion, and then that's going to increase the radius, so it does the exact opposite of the cation. So following that rule, sodium is going to be larger than sodium with a positive charge because it's lost an electron there, so it's going to be smaller. And then actually I'm looking at this, I did this wrong. So it's actually going to be the nitrogen is going to be smaller. I'm correcting myself here. The nitrogen is smaller than the one with the 3- charge. This 3-1 charge is going to be larger because it's going to be more negative. So I'm going to correct my answer, and that's why I like doing this, because I can actually talk about my problems out loud. So nitrogen on its own is going to be smaller. If I had a pen right now, I'd correct that, but I don't know where it is. So with ionization energy, as atomic radius increases, the ionization energy decreases. The first ionization energies decrease down a group and increase across a period. Fluoride or fluorine is going to have a larger first ionization energy than iodine because it's higher than iodine on the periodic table, so that's a smaller radius. So it's inversely related, so it's going to have that larger first ionization energy. With the smaller first ionization energy, sodium is the first in the period and sulfur is further across, so sulfur is going to have the smaller radius. So electron affinity generally increases or becomes more negative across the period. So the higher electron affinity here, so selenium had -195, chromium had -324, so that one is going to be higher, it's more negative. And then more metallic character is going to be cesium, and then the less is going to be there. So it's easier to add on an electron across a series of atoms as the nuclear charge of the atom increases. I just wrote that down for more information for myself with this electron affinity chart. I just wanted to add that in. That's how I got all my answers. And if you move left to right, the electron affinity becomes more negative, so the atom at the top will also be more negative. And then how I found the metallic properties. Metallic properties depend on having electrons that can be removed easily. So the metallic character will increase down a group and decrease across a period. And that's all I got. Thank you.